Hello everyone. We have seen how to add something to functions. We have seen how to multiply something by functions. Now we are going to have a look at what happens when we combine that if we first do one and then the other. We will first have a look at what happens with order. Does it matter? Can I just use either order or does it give a different function? And then, well, we can have a look at how we do these things, but it's really just literally combining what we've done before. So we will have a look at how we can find out what happened if they tell us that something is moved and then stretched, or stretched and then moved. How much has it moved and by what factor has it been stretched? That is what we're going to look at in this video. So first off, does the order matter? Well, you can probably already guess by the fact that we're discussing this and by the fact that the next topics are split up, but let's have a look. And we're just going to do that with one of the simpler functions, just a simple parabola. And we're going to have a look what happens if we move it 3 up and then stretch it by a factor of 2. And we're also going to have a look at what happens if we take that exact same function, but we first stretch by a factor of 2 and then move 3 up. So we have our parabola, and then we're first going to get some in-between step where everything is just moved 3 up. So that's this one, and the function of that is given by x squared plus 3 because it's just moved 3 up. And then this new function, g of x, is stretched by a factor of 2. So we end up finally with this graph, somewhat off screen. And because each term is multiplied by 2, that gives us this final function. X squared times 2 is 2x squared, 3 times 2, 6. Okay, sure, that's one order. Let's try it the other way around. Again, we start with this simple parabola, and we first stretch by a factor of 2, so we first change the shape. But this point at the bottom at the origin stays at the origin. So we just have 2x squared. And now we move 3 up. So our function is just 2x squared plus 3. And you can see both in the graph and in the formulas, in the functions, that these are not the same. So unfortunately, yes, order does matter. So you always have to be careful which order you used, which order has been asked. All right, now for some detective work. Suppose you are given a certain function and you've been told that it's first moved and then stretched to give a new function. So it's first been moved. You know that something has been added or maybe subtracted to give some in-between function. And then it has been multiplied by something to give the final function. Now, important to note here is that stretching is going to change all terms. Every term is multiplied by the factor. But moving only changes the number added at the end. So when it's being moved, this bit is not going to change. Meaning, we do know that this in-between function still has that 3x squared plus 4x. But if we know that, we can find out what it's been multiplied by. From 3x squared to 15x squared, from 4x to 20x, that's been multiplied by 5. But if that's been multiplied by 5, well, then the number there must have been 2. Because 2 times 5 is going to become 10. And then I can figure out what has been added, how much has it been moved. From minus 5 to 2, it's been moved 7. So I can conclude it's been moved 7 up and then stretched by a factor of 5 parallel to the y-axis. So how did we do that? We started by figuring out the stretch, looking at the terms with an x. Then we figured out the last bit of the in-between function. And once we've got that, we can figure out how much it has been moved. Okay, that was moved then stretched. Now let's have a look at what happens when it's first stretched and then moved. We're going to start with the same function, but this time it ends up here. And it's been stretched first, so there's some in-between function. That is a multiplication of the first one, and then something has been added. And the same notes are true. Stretching still changes everything, but moving, the adding, still only changes that final number. So this time, it's this bit that's the same here, because the plus is not going to change that. So we know our in-between function looks like this. But then again, we can find out what is it multiplied by? Well, 3x squared to 9x squared, 4x to 12x, that's multiplied by 3. And then we can also figure out minus 5 times 3, that number there must be minus 15. And then finally, we can figure out, well, how much has been added or subtracted to get from minus 15 to minus 10. Well, clearly we have added 5 there. So what happened to this graph? It has first been stretched parallel to the y-axis by a factor of 3, and then it's been moved 5 up. How did we do that? We took the exact same steps as before. We started by figuring out the stretch, looking at the terms with x, then we figured out the last bit of the in-between function, and lastly we figured out how much it has been moved. The only difference is that now we have taken this bit from the bottom part, from the final function, as opposed to from the starting function. And that's because we now have the plus at the end. That's the only difference between the example with moving then stretching and the example with stretching then moving. So that's all I had to say about those combinations. It might still be a little confusing what happens exactly with stretching and then moving, or moving and then stretching. But I hope with some practicing you can figure out what happens when you combine moving vertically and stretching parallel to the y-axis.